introduction, and then please with let's say coming back for let's say for the last 2 months or a bit more time, 10 days. That's the next event, and of course also discussions about whether new terms of how to integrate them into the current project. So we also not only have to talk, but also demos. So both of this will work. And demo. We try. We try. So maybe I'll start with saying some words to define beforehand. And we are consultancy, so we are focusing mainly on the what is in between the domain-specific know-how and some tech in general. And so we are doing that for several industries, not only in the automotive sector, but also for 20 years in the farm sector and in the energy sector, of course, and in mobility. What we bring on the table, this is a combination of domains, specific know-how, so the data, and then the data analytics are data science, entity science, of course. And we love to do things. Also, and focus here on Ankaios project. We need to build some stuff and bring it to life. So, and we are present in automotive sector development, and we were speaking where we can start in terms of where we can start in terms of code to road, let's say it that way, software-defined vehicle development. And we were thinking, of course, maybe we are supporting an open source community, so the Eclipse Foundation, and we were looking what project is it to start, and then we came up with a nice Ankaios opportunity to support the dashboard. In general, open source, we are doing a lot open source as a company, so we are very, let's say, present in the energy sector, in the Linux Foundation. Then we do a lot of stuff in the Gaia X related project, where there's also code, of course, published. And from time to time, we have also some colleagues who love to support let's say, standard library development. For instance, we have one colleague who is working on the pandas and the Python framework in the pandas library very actively. So maybe with this words, I'm handing over to Ömür. To introduce the Ankaios dashboard, when all these things come together on a table, and we will see then the demo session, which we built in the last 2 months. So, Ömür, please.
Thank you very much, Thorsten. Hello, everybody from my side. I apologize in advance for the stuffy nose. It's allergy season, and like most engineers, I wasn't allowed to play outside as a kid, so this is what I get for it. Right. Before we dive into the Ankaios dashboard, let me just quickly give you a recap of what Ankaios. We have Holger sitting here in the audience already. Just yell at me if I say something wrong. So basically, in a nutshell, it is an open source workload and container orchestration tool for automotive high-performance computing. Workload orchestration in the sense that we can start, stop, configure, and update workloads using a server and multiple agents. We can manage containerized applications, and Ankaios has been built specifically with the automotive use cases in mind. So think about applications running in the infotainment, running in the drivetrain, connecting the car to network services, and so on. So all of this can be orchestrated and managed with the Ankaios software. As great as Ankaios is, and it's very, very good, there's always ways to improve on a project, and a possibility to add a little bit into this project would be to create this dashboard that we want to talk about. So the status quo right now is that the user interacts with Ankaios mainly by the command line interface. So we use commands like get workloads and so on to use text prompts and get information from the software. We see, for example, a text-based overview in our console window showing us the workloads that are running, that are active, waiting to start, and so on. Now, the challenge here would be that not all information is displayed in this specific view. For example, information on tags and dependencies is not displayed here right away. Some prompts display the information in much more detail, we will see in a second, but text alone can become quickly overwhelming with lots of workloads. So imagine you don't have 5 or 6 or 7 workloads, but 50, 100 or 200 workloads running at once. So looking only at text can be a bit overwhelming. Improvements or ideas for improvement would be to have a graphical interface that summarizes important information and displays it in a concise and neat way. And it would be also nice to have buttons, interfaces like drop-down menus to evaluate some of the workloads more in depth and allow interactive management of the workloads. So moving on from this text-based world, we have a first teaser here for the home view of the newly developed Ankaios dashboard, where we have an entry point to the application here in this home view, which briefly summarizes the core stats of the workload in the sort of top area here, with the number of workloads, agents, dependencies, and so on. Below that, we have these donut charts that illustrate the distribution of workload per agent, for example, and the workload states. So important information can be graphically displayed immediately to get the information at first glance. More details on the workloads can then be taken from the table here, where we have, besides the names and agents assigned to them, dependencies and tags, for example, as well as their state. And we also have filtering operations built in, so you can quickly find the workload you're looking for. Right. With that as the first teaser, I will now try my luck to do the live presentation. And apparently, do we need a microphone? Yeah, we need a microphone holder. Give me a second. So what I've opened here, you should hopefully see. Yes, I hope I'm not too clumsy and in the way. I'm sort of in between. So we see here the configuration file for our Ankaios dashboard, or Ankaios in general, I should say. I started this process now. You notice that the Ankaios dashboard itself is a workload defined here in the config file, which is currently commented out. So it's not running yet. We can use information. We can use text prompts like get_state to get much more detailed information on the workloads. For example, here we can see that there is a process. Oh, let me move up a little bit. We can see a process here called automatic climate control. And we see here several tags that are associated with this process. For example, that is started by the front passenger, it's running in the AC unit, and so on. And we also would see dependency information. So for example, in order for workload A to be able to start, workload B would need to be running. Again, we see this information in a text-based environment. What I can do now is comment out, or comment back in, I should say, the dashboard itself and apply this updated configuration. And notice now that the dashboard itself is starting. We can now move to our browser window. And we should hopefully see the dashboard running now. That's all right. What we see first is a login message. Of course, we shall comply and use the world's safest username password combination. We log in and we are presented with the home view of the dashboard, which is this view that you've seen before. We have the amount of workloads, we have the distribution between agents and so on. Down here, we can have a look at all the workloads in real time, see their dependencies, see their states, and see the tags associated with them. And hovering over the graphs, for example, gives us more information on what percentage, for example, is running on which or with which agent. Moving on to the next screen, which would be the workload overview. This is sort of the centerpiece of this workload view here. We have each workload defined as a single card based on material design. So if we look again at this automatic climate control workload, we see its state. It is running with the green indicator. We see the agent that is associated to it. We see the tags that are associated to it. And we have 3 buttons that we can control or modify this workload with. Firstly, of course, quite intuitive, the delete button. I won't do that just now. So we got a little confirmation window here. I will click cancel for now, but we can delete the workload here right away. The second button would be a config window where the card extends downwards, a nice little animation, and we can now start editing the information on the config of this workload. For example, we could change the port associated, we can change the image and so on. I will leave it for now. And the third button here gives a few more information on the state and dependencies. So we have here the state running again with the substate running okay. And we see that there are no dependencies here again as indicated by these green dots. If we, for example, move now to the workload navigation, which is also running, this one has a dependency that the workload named infotainment screen on has to be active as well. And as we see here, this is the case. The condition that it is running is a match. So that's all good. Next up, I want to show you a third workload, which is pending. Upon further inspection, we see that it is pending and waiting to start because now a dependency is missing. The workload smartphone Bluetooth connection. It is not started here. What we can do now is manually add this workload via the interface. No typos now, please. We have drop-down menus to select agents. We choose agent A. We can select a runtime, restart policy, and we can give this workload some tags. Let me just quickly choose some random tags here. Let's say running in. And I'll just add infotainment. Lastly, we define the image. So far, so good, everything live. And let's assign port 5010 to it. Should all be good. I think that looks fine. Now, please notice as this workload will hopefully start and turn green into state running, the workload smartphone music streaming should immediately recognize that. The data comes from the back end, gets communicated to the dashboard, and smartphone music streaming is shown as running also. Let's try it out. Did I have a typo?
Drum roll.
I think I might have added a typo somewhere. Oh yeah, right. I forgot, of course. Now it should be.
You said we were brave to do a live demo.
Oh, there's still a comma mistake here. There we go.
All right. Woo.
You could have told me there was a comma there. All right, so we see that now both workloads are green. The dependency is met. Smartphone Bluetooth connection is indeed a match, and it's running fine. The last page I want to show you quickly is the dependency view. Here we have this sort of little network arrangement of the workloads, where each workload is a node, and each node can have a connection via these arrows here, where green arrows stand for a condition that the workload needs to be running in order for the other workload to run, as we've seen here in this case. smartphone music streaming has to have smartphone Bluetooth connection running in order for the music streaming workload to start. Other examples would be here, EV charging error and EV charging start. In order for the system to throw the charging error, the infotainment screen has to be on, and the charging start workload would need to fail. And last thing, I think I can show you how to delete a workload once more because I've glossed over this just to make sure you can see this, and it's deleted. And with this, I think I conclude the live demonstration, and I would switch back to the presentation for Felix.
Thank you very much, Imre, for the live presentation and being so brave. As this is a open source project, of course, we now started implementing everything. I want to give you some information on how to participate and give you the relevant information to have you having a quick start getting into the project. So as you can see, the dashboard we have built is a client-server application segregated into the client part. In this case, it was written in the Quasar framework that is based on Vue.js. It's very performant, uses material design. As you can see, it looks crisp and modern. And furthermore, as we want others to contribute, it has a very comprehensive and clear documentation. So it is for everyone who has already done some web development, easy to get and change some things if you need other information. The second thing is the backend. We decided not to write in Rust. We have chosen to use Python because we wanted to make it as easy as possible, as we see this more or less as a dev tool for everyone to join. Python is well known, has a lot of different libraries. For example, the library Flask that we use for the REST API endpoint. It is very, very fast. It has still a big variety of control mechanisms. I mean, you can have a very fine-grained control on everything, on the endpoints especially. And the last thing I want to emphasize right now, the communication between front-end and back-end is done via HTTP. We are planning to, in the future, as the Ankaios system is also going to a more secure implementation, also with authentication and certificates, to change this to HTTPS. And if you didn't know yet, the communication to the Ankaios system in the backend is working through gRPC calls, through so-called named pipes within the container. Second thing, as you already saw in the demonstration, if you want to start right away, you can take the config, either put it to the startup state YAML file of the Ankaios system, or you can, if you run into any errors or bugs in the system, you can just start it at runtime to do the debugging using the dashboard. One thing that came up during the Ankaios community meeting was the question if you could use that dashboard for multiple clusters. That is not possible due to the design and architecture of the Ankaios system. Every cluster needs one workload, the dashboard as a workload deployed in that. Currently, it is tested with 0.3 version. We had a discussion today on the versioning, how we will have a mapping table in the GitHub repository later on. Yeah, and that's one thing I want to show you if you're interested in getting started with development in the dashboard. 1 second, should be running soon. Can I confirm, Imre?
Sure.
Okay. So there's just 3 things I want to emphasize. First, you find the documentation there, how it is built, what technologies, and how to start right away. And one thing that people should know, if you don't change it, the world's safest password, of course. The second thing is we decided as the colleagues from Electrobit to work with Visual Studio Code. We provide a container that you can use for the development. You find it here in the dev container subfolder. And the third thing is we also provide for the development in the container a shell script that you can just build and run the Ankaios dashboard within the system. So now I'm trying to find the PowerPoint presentation again. This one was it not.
Alt-Tab.
Finally, we have it here. Okay. On the current slide. So to wrap everything up, we presented to you today the Ankaios dashboard. You can use it for your future development with the Ankaios system. If you haven't used Ankaios yet, I think it might get a little bit clearer what Ankaios is and how you can get easy into the project and start using it. Also, we want to show a roadmap where we're going. I already said that we are thinking about changing to HTTPS. Another thing would be of interest for everybody who's developing. What are the resource usages of the different workloads? Therefore, we would have to develop an agent in the future that is put into every workload. We're still thinking about how to do that, but this is just the roadmap. And we had another discussion on the dependency graph that you just saw. As you're having more and more resources in the system, it is very hard to configure it by hand and write the text down. So we are thinking about a config creator somehow that you can define the graph and later on get the configuration spit out so you can use and start with it right away. With that, I want to thank you for your attention. I hope you are as hyped as we are about the dashboard. We want to thank Holger and Kalian from Electrobit for boarding us on as easy so we could start right away with developing. And if you have any questions or comments, you can ask them now. We are looking forward to having your feedback. Thank you. Yeah.
So first question is, I'm new to other projects. Another couple of projects that are workload orchestrations. How portable is this dashboard?
It's very portable. The one thing we have to change, we built with a layered architecture. We have a service that is there for the communication, and you would have to exchange the backend that is specialized on the Ankaios system. So the communication with the control interface. So we already thought about that. So if there's another system, you could also use it. Yeah. Right now, yes, it is. We were already chatting about how to change that in the future. As you know, we are not yet a member of Eclipse community. We're just individual contributor until now. So right now it's in that repository, but we're thinking about changing that location. Mm-hmm.
I have a question. A question to my colleague from the Teams chat. Can you speak more about the possible usage scenarios we could aim for with Ankaios? Oh, now it scrolled up. Sorry. Thank you. The dashboard demo was interacting with one vehicle as far as I can see. So is the dashboard for use during development testing and not after selling vehicles? Is this to support development of a container-centric implementation on the vehicle? Or is the idea to also have a dashboard to control functions on fleets of sold or deployed vehicles?
Very good question. We didn't think of the latter one yet. We thought of the system right now as a development tool during development process and to speed everything up. And as he in the comment or she, or yeah, I don't know the pronoun, anyway, said it is within just one cluster. You can access it via the usual IP connection. You need one, but then you can access it from everywhere. Yeah, I hope that answers the question from the chat.
There's one more question, also from Gunnar Anderson. What is the meaning of the word cluster in the vehicle case? Is it multiple ECUs, computing units that you can deploy on? Are you using the word cluster in the same way as Kubernetes, for example?
Very interesting question. So the Ankaios system is built that way that you have one server and multiple agents. And the agents can be deployed on different ECUs. So that is meant by the cluster. The cluster can either be multiple agents on one ECU or HPC in that manner, but it could also be different hardware components that are connected to the server. This is meant by a cluster. So a cluster is one server with multiple agents.